If you could gaze into Mock's class, you might think Chem would be a breeze.
Chem is a breeze.
See gas laws from a distance, yeah. Go Mock, but it's not that easy. Oh Mock, I try to save my grade in Mock's class, but I end up just failing. Hey now, say now, about to put it down, yeah. Come on, ride with Mock now. You know Chem looks great now, and everything's gonna change now. Go Mock. That's so Raven. It's the chemistry we see. That's so it's so mysterious to me. That's so Raven. It's the chemistry we see. That's so Raven. It's mysterious to me. Yeah, that's me.
Hey y'all. Eddie. Why? Don't you have a test? Oh, yeah, dude. Turn that off, man. Turn it off. Go home, Eddie. Shut up, turn it off. What, Raven? It's gonna be bad. You're gonna fail your test. And you guys gotta help me study. Maybe Chelsea can help you study.
Oh my god, guys. I just took the hardest test of my life.
What was it on?
Something like the gas laws? I don't know.
I'm serious. I'm gonna fail this, you know? Maybe Chelsea
I'm gonna
can
fail
help
this
you out. Maybe Chelsea can help you out. Yeah. What's your test on, Eddie?
I don't know, but did you see anything that was on the test?
I saw Boyle's law, Charles' law, Gay-Lussac's law, the ideal gas law, and something with Graham and Dalton.
Okay.
What about kinetic molecular theory? Have you guys been learning about that?
Yeah, the molecules of kinetics, right?
Chelsea, the kinetic molecular theory.
I'm sorry.
Come help me study, please.
Yeah, let's go outside.
Okay.
So Eddie, we made you a bunch of flashcards right now with every single thing that Raven saw on the test. So let's just go through all of them and see if you know.
Okay.
What you need to know is Graham's law of
Like graham
diffusion.
crackers.
Oh my god. Chelsea, focus.
I'm sorry.
I'm trying to learn here. Okay, so the next thing you need to know is Graham's law of diffusion or effusion. And this law states that rate of the diffusion of a gas is inversely proportional to the square root of its density or molecular mass. So the equation for Graham's law is kind of scary looking. So it's rate A divided by rate B equals to the square root of the molecular mass of B over the molecular mass of A. I know it looks kind of scary,
It does.
but it's not that bad.
Okay, this probably won't even be on the test.
Wow, this looks like adding.
Actually, it's Dalton's law. It's total pressure equals P1 plus P2 plus P3.
All right, Chelsea. Might I add, it continues for as many pressure values as there is given.
Yeah, I knew that.
All right, Chelsea.
Okay.
You know the definition?
Oh, the definition is in a mixture of non-reacting gases, the total pressure exerted is equal to the sum of the partial pressures of the individual gases.
Okay. I get it. So another very important one you need to know, Eddie, is the combined gas laws, because it combines every single gas law's aspects into one equation. So the combined gas laws equation is the initial pressure times the initial volume all over the initial temperature, and that equals to the final pressure times the final volume over the final temperature. Does this make sense, the equation so
Yeah.
far?
Pretty confusing, but yeah, I get it.
Okay. Do you get which each variable is and everything?
Yeah, that's pressure, that's volume,
And what's this?
that's temperature.
Okay, you're all good.
All right.
Was this on the test?
You mean the molecular kinetics?
Yes, Chelsea, the kinetic molecular theory.
Oh, yeah.
Types of gases. There's ideal gases and there's real gases. Ideal gases always follow the kinetic molecular theory, but real gases do not. Ideal gases don't exist, but under conditions of low pressure and high temperature, real gases behave like ideal gases. So there's 6 rules of the kinetic molecular theory. You
Wait,
gotta
guys,
remember-
look.
Chelsea!
Sorry.
Okay, anyways, come on, are you listening, Eddie? Yeah, I'm listening. Okay, so there's 6 rules of the kinetic molecular theory. Rule number 1 is particles are so small that they have no volume. Rule number 2 is particles are in constant random motion. Number 3 is gas particles do not interact with each other. Rule number 4 is the kinetic energy of the particles is proportional to temperature. Rule number 5 is particles undergo perfect elastic collisions. And number 6 is gases have mass. And the last thing you'll need to know about the kinetic molecular theory is the factors that affect the behavior of gases. So let's make sure this doesn't fly away. So there's 4 factors that affect it. It's mass, volume, pressure, and temperature. So that should be everything you need to know, right, Chelsea? Nothing else like this is on the test about kinetic molecular theory?
Yeah, I think that's right.
Okay.
Okay, so the next one is the Boyle's law. It's pretty easy.
Oh wait, I know this one. Boyle's law, you mean?
Oh, okay. I didn't think it was that, but okay. So the equation is initial pressure times initial volume equals final pressure times final volume.
Alright, that sounds easy.
Okay, Boyle's law is a gas law stating that pressure and volume of a gas have an inverse relationship when temperature is held constant.
Okay, I think
Does that make sense?
Yeah.
So Charles' law is the initial volume over the initial temperature equals the final volume over the final temperature.
And this is Charles' law, right?
Yeah, Charles' law. So as the temperature of the gas increases, the volume increases proportionally, provided that the pressure and the amount of gas remain constant.
Okay.
Okay, go.
What law is this? It says the principle that for relatively low pressures that the density of an ideal gas at constant pressure varies inversely with the absolute temperature of the gas. What is that?
This is Gay-Lussac's law, and it's that the initial pressure over the initial temperature equals the final pressure over the final temperature.
All right.
So now we're gonna figure out ways to use real life examples with the laws, with the gas laws. So I'm gonna tell you this word problem. So the gas in an aerosol can, this dry shampoo can, is at a pressure of 3 atm at 25 degrees Celsius. The temperature increased to 52 degrees Celsius. So what would the gas pressure be at 52 degrees Celsius?
So the equation is initial pressure over initial temperature, which equals final pressure over final temperature. You would have to convert to Kelvin, and you would do that by adding 273 degrees Celsius. And I think you would have to cross multiply and divide it, and that would get your final answer.
Okay, so another example is Charles' law, and a basketball filled with air has a volume of 2.75 liters at a temperature of 18 degrees Celsius. What's the basketball's volume at 45 degrees Celsius?
Equation for this one is initial volume over initial temperature, which equals final volume over final temperature. Charles' law changes degrees Celsius to Kelvin by adding 273. You would have to cross multiply and divide, just like Gay-Lussac's law.
Okay, so another example is a dry shampoo can has a volume of 2 liters and it is filled with a gas at 3 atmospheres. If the pressure is reduced to 1 atmosphere, what is the volume at a constant temperature?
Is this Boyle's law?
Yeah.
I think for this one, you would have to plug in all the values, multiply and divide to find your final answer.
Yeah.